All right, so we're going to start chapter 1, section 6c. This one we're just doing rational equations. We're not going to do the absolute value with this one. Now, we've done rational equations before in, I believe, chapter 1.2. We're just going to keep going with these because in this one we're able to get quadratics as the equation, as the leftover equations that we need to solve. Right, so it's going to be the same process as clearing the denominators. Just the type of equation that you're going to be left with are things that now we're able to solve. So again, the process is exactly the same. You want to find the least common denominator and multiply each term by it to cancel it out. And you want to check for extraneous solutions, right? This process isn't nearly as tedious as in the last section, right? You're just checking for the denominator to see if it equals 0. Because remember, a 0 on top, that is okay. But a 0 on the bottom, no, that is not okay, right? So 0, this is undefined. So the only thing that you're checking, you just need to plug your answer into the denominator and see if it equals 0. So let's try a couple examples. Let's look at this first one. Our fractions here, we have 4 in the denominator and we also have an x plus 1 in the denominator. So the process is going to be the same as the last time I taught it, right? So you want to you're going to multiply the entire equation by a common denominator. And a common denominator here is going to be 4 and x plus 1. All right, so let's distribute 4 times x plus 1 to this entire thing. And now when you multiply 4 times x plus 1 to 4x plus 3, the 4's are going to cancel, right? The 4 on top and 4 on the bottom is going to cancel. So we get 4x plus 3, all right, times x plus 1. All right, and then we get minus, and then here the x plus 1 is going to cancel with this x plus 1. So you're just left with that 4. So that 4 is still there since we're multiplying it to each fraction. So minus 4 times 2x, and then it's going to equal, there's nothing to cancel here, so we get 4 times x plus 1 on the other side of the equal sign. And now this, we just want to distribute everything, multiply, FOIL, simplify it, all that stuff, right? So let's FOIL this side, and we should get 4x squared plus 4x plus 3x plus 3. And then negative 4 times 2x is going to be a negative 8x. And this is going to equal, we can distribute 4x to everything. It's going to be 4x squared plus 4x. All right, and now let's combine like terms. All right, so 4x and 3x is going to become a 7x. And then 7x minus 8x, right, that's going to become negative x. Right, and there's nothing with 4x squared and 3 to combine with. Right, so this 3 and this 4x squared, nothing to combine, so you just leave those alone. And then equals 4x squared plus 4x. Now we see a quadratic. Our instinct should be to see if we can get everything to one side and factor. Right, but notice that when you try to do that here, right, if you subtract 4x squared from both sides, it just cancels out completely, right? So we're left with a negative x plus 3 equals 4x. And then we want to add x on both sides. And we're just going to solve for x. So we get 3 equals 5x. Divide both sides by 5. And we get x equals 3/5. All right. And now you want to check if this is going to give you an extraneous solution, right? But our only variable in the denominator is going to be this one here with the x plus 1. And of course, 3/5 plus 1 is not going to get you 0, right? So this is a valid solution. All right. And number 2, it's going to be the exact same process, right? So you're just looking in your denominator, and you're going to see what you need to multiply the entire equation by to cancel it out. Here we have an x minus 4 and an x minus 4. So we just need to multiply one time x minus 4 to the entire equation to cancel it out. All right, and then this x over x minus 4 is just going to become an x, right, since this cancels with this. Same thing with that 4, right? This x minus 4 is going to cancel with this x minus 4, so we're just left with 4. And then there's nothing to cancel over here, so we get plus 4 times x minus 4. All right, let's distribute the 4 and let's solve for x. So we get x equals 4 plus 4x minus 16. And then combine like terms. So we get x equals 4x minus 12. And then let's solve for x, right? So we can subtract 4x on both sides, right? This step, or these steps right here, this is algebra 1, right? So solving the single exponent, like if there's nothing over the exponent, then this should be a pretty simple equation to solve, right? The hard part was just getting that those fractions out of there. So you get x equals 4. Right, but when you plug this back into the denominator, are you going to get 0? Right, so if you plug in a 4 here, we get 4 minus 4. That does equal 0, right? You don't want a 0 in the denominator, so this is actually a no solution. All right, so you always want to check, right? And the check here isn't super difficult. You're just checking. When you plug it into the bottom, are you going to get 0? In this case, you do. All right. Now let's look at the next one, right? Should work out in a similar manner, right? So why don't we check and see what our denominators are? So we have an x minus 2, an x plus 2, and an x squared minus 4. Now you want to check if you can factor anything in the bottom first, right? Because you don't want to rush into multiplying everything by x minus 2, x plus 2, and x squared minus 4, right? Because that might be a little too much, right? Let's see if it is, right? We have an x minus 2 and an x plus 2 here, right? That's how this x squared minus 4 is going to factor. It's a difference of squares. And you can see that these match the denominators that we have here, right? So there's no need to multiply by everything, right? You just need to multiply it by enough to cancel out your denominators, right? So multiply this entire thing by x minus 2 and x plus 2. Right, when you distribute, what's going to cancel in the 3 over x minus 2? It's going to be the x minus 2. So you're just going to be left with 3 times x plus 2. All right, plus, and then 1 over x plus 2. The x plus 2 is going to cancel. So you're going to be left with a 1 and an x minus 2. And then on the other side of the equal sign, everything on the bottom is going to cancel with all of the factors, x minus 2 and x plus 2. So you're just going to be left with a 12. All right, now from here, again, this is an algebra 1 skill, right? You should know how to distribute the 3 and the 1, right? But I'll go through it still, right? So distributing the 3 is going to be a 3x plus 6, all right? You don't have to write the 1 and distribute it because anything times 1 is itself. But if you wrote it, if you distribute the 1, it's going to be an x minus 2 equals 12, right? So just combine like terms and solve for x. So we get a 3 plus x is going to be a 4x. 6 minus 2 is going to get you 4. So 4x plus 4 equals 12. And let's subtract 4 on both sides. We should get 4x equals 8. Divide both sides by 4. And we get x equals 2. All right, so all of our algebra was correct. But when you plug it back into the denominator, right, do we get 0 anywhere? We do. We get a 0 right here, right? When we plug it in here, we get 2 minus 2 equals 0, right? And that doesn't work. Now, a good question that I got today was, it works for this one, though. This is a 2 plus 2. That equals 4, right? If it doesn't work for one of them, then it can't work for the entire equation, right? So even, it just takes once, right, for it to not work. So x minus 2 is, or x equals 2 is not a solution. This is going to be another no solution. All right, so it's important that you're always checking. All right, so we're going to finish with these today. Looking at this one, all right, this looks like a really complicated problem, right? It looks like there's so much going on, right? But just like the last one, we want to try and factor everything first. All right, so let's check the denominators. Let's start here. X squared plus x minus 2. That can factor into an x plus 2 and an x minus 1. you're looking for factors that multiply to negative 2 and add to positive 1. All right, so an x squared minus 1 should get you also an x plus 1 and an x minus 1. Right, so again, this is a difference of perfect squares. Right, and then the next one, first we want to pull out the GCF. Right, always check if there's a GCF first. So we pull out the GCF, we get x squared plus 3x plus 2. And then the inside factors. So we should get 2 times x plus 2, x plus 1, right? Factors of 2 that add up to 3. All right, so there's a lot of factors here to keep track of, right? So let me write the parentheses, and we're going to multiply by, let's go one by one. So there's an x plus 2 here, and there's an x plus 2 here. All right, so we should multiply by an x plus 2. All right, so there's that one. And then there's also an x minus 1 and an x minus 1. All right, so we're going to multiply by that as well. All right, and then there is also an x plus 1 and another x plus 1. So we're going to multiply by that as well. All right, and then there is also a 2. Okay, just a regular 2. So we're going to multiply by that 2 as well. And now we have 4 factors to multiply by, right? But I don't want to write the entire thing out. Why don't we distribute to each term and then just see what cancels out, right? And I highlighted it for your convenience, right? The x plus 2 and the x minus 1, so the kind of that reddish color and the purple are going to cancel out. And you're just going to be left with that green and the blue. So we get 3 times 2 times x plus 1, right? Because the x plus 2 and the x minus 1 canceled with these right here. All right, and the same thing with the next one. We get a minus 1. And now the x plus 1 and the x minus 1 are going to cancel out, and you're left with a 2 and an x plus 2. On the other side of the equation, the 2 is going to cancel out with that 2. The x plus 2 is going to cancel with the x plus 2, and the x plus 1 is going to cancel with the x plus 1. You just are left with the x minus 1, so 7 times x minus 1. All right? And now you just want to solve for x. Right? The hardest part was canceling things out and multiplying by that denominator. Right? But once we get that, it's just a one variable linear equation. Right? So we get 3 times 2, which is 6. And then when we distribute 6 here, we get a 6x plus 6. Negative 1 times 2 is negative 2. And then when we distribute negative 2, we should get a negative 2x minus 4. And then when we distribute 7, we should get a 7x minus 7. And then combine like terms, we should get a 6x minus 2x is going to get us a 4x. 6 minus 4 is going to get us a plus 2 equals a 7x minus 7. All right, and now let's get everything one side. Or no, let's get the x's on one side, the constants on the other. All right, so let's subtract 7x and subtract 2. All right, so we should get negative 3x, all right, equals negative 9. And then you divide both sides by negative 3, and you get x equals positive 3. All right. And then when you plug it back into the denominator, you're not going to get a 0 anywhere, right? So this solution works. All right. That was maybe the hardest one that you'll see today, just because there's a lot of factors to keep track of. All right, so let's keep going. Let's look at the next one. Again, as always, anytime you have multiple denominators, you want to see if you can factor any of them. Right, and this last one you can factor. You can pull out an x as a GCF, and then you're left with an x plus 1. All right, and then conveniently for us, those match the other two denominators. So all you have to do is multiply this entire equation by x times x plus 1. And then distribute to everything. The x plus 1 and the x plus 1 here are going to cancel, so we get an x times 4x plus 3. The x and the x are going to cancel here, so we get plus 2 times x plus 1 equals, and then the x plus 1, x plus 1 are going to cancel. So this equals 1. All right, now let's distribute. All right, so we get 4x squared plus 3x plus 2x plus 2, and we get that after distributing. This equals 1. All right, we have a squared term here. Like I said in the very beginning, the only difference between this section and the last time that I taught it in 1.2 is the fact that here you're going to get other types of equations that now you should be able to solve. All right, so this is just another quadratic equation. Let's combine like terms. So we're going to get 5x, and let's subtract the 1 on both sides to set it equal to 0. So we get 5x plus 1 equals 0, right? Bring down the 4x squared. 4x squared plus 5x plus 1 equals 0. And now let's see if we can factor this, right? So factors of 4 times 1, again, if there's something in front of the x squared, you want to multiply the first term and the last term. So factors of 4 that add to 5 should just be 4 and 1. All right, and then you want to split up the middle term and factor it by grouping. All right, and now to group the first two, group the second two. All right, and then GCF of the first is going to be a 4x, and then you're left with an x plus 1. GCF of the second is going to be a 1, and you're left with an x plus 1 equals 0. And then we can factor as 4x plus 1 times x plus 1 equals 0. And then we should get x equals negative 1 and x equals negative 1/4. When you plug in negative 1/4 into the denominator, you're not going to get 0. But when you plug in a negative 1, here you get a 0. We get negative 1 plus 1. That is 0, right? So negative 1 is not a solution. It would just be negative 1/4. All right. And now let's try the last one. All right, so we have a 2x minus 3 squared in the denominator and just a regular 2x minus 3. So let's multiply this entire thing by 2x minus 3 squared, right? Because even though it is the same factor, right, it shows up twice under the same fraction, right? If it's under the same fraction and it's squared, you can multiply it twice, right, to cancel out that entire denominator. And then when you distribute it to each term, you get 6 times 2x minus 3 squared, all right, equals 7 times 2x minus 3, right, just one time, right, because if it was 2 that you multiplied by, that's going to cancel with the 1 on the bottom. And then plus 3, right, because if you had 2 on the bottom and 2 on the top, then they're going to cancel out. All right, so let's, we can distribute the 7, and we can also FOIL this 2x minus 3 squared, right? So if you wanted to FOIL it out, right, we can write out 2x minus 3 twice. And then I'll take care of the 7 first. So distributing the 7, we get 14x minus 21 plus 3. All right, and then FOILing 2x minus 3 times 2x minus 3 should get us a 4x squared minus 12x plus 9. Right, and this is all times 6. All right, and this is equal to, we can combine negative 21 and 3 to get negative 18. So we get 14x minus 18. And then distribute 6 to everything. And we get 24x squared minus 72x plus 54 equals 14x minus 18. All right. And let's get everything to one side, right? There is another square term just like the last one. So let's get everything to one side. All right, and then set it equal to 0. So we get 24x squared minus 86x plus 72 equals 0. Right, so always check if you can pull out a GCF. Here we can pull out a 2. Right, so when you pull out the 2, you should be left with 12x squared minus 43x plus 36 equals 0. And then to get rid of that 2 entirely, let's just divide everything by that 2. Right, so to cancel it out here. So we get 12x squared minus 43x plus 36 equals 0, right? 0 over 2, that is okay. All right, so this equals 0. And then now you want to factor, right? This is another hard one. This one is just hard because of the factoring, right? You get big numbers, right? 12 times 36 should get you, I have it right here, 432. And then you want factors of 432 that add to negative 43. All right, so it should be two negative numbers. Since you want them to multiply to a positive number and add to a negative one, should be two negative numbers. All right, so here it should be negative 27 and negative 16. Right, that multiplies to 432 and adds to negative 43. Right, so let's split up the middle term and factor by grouping. So we get 12x squared minus 27x minus 16x plus 36 equals 0. All right, group the first two, group the second two, and then you can pull out from the first one, looks like you can pull out a 3x. All right, when you pull out a 3x, you're left with 4x minus 9. And then from the second group, it looks like you can pull out a negative 4. And then when you pull out a negative 4, you're left with a 4x minus 9 as well. All right, and so we should get 3x minus 4 times 4x minus 9 equals 0. All right, and then we set both of these factors equal to 0. All right, add the 4. We should get x equals 4 over 3. All right, so add the 4 and then divide by 3, and then over here we should get x equals 9 over 4. All right, add the 9 and then divide by 4. All right, and then we're not going to get 0 in the denominators, right? This one was a big problem just because of the big numbers that we had to factor, right? But again, conceptually, everything is the same, guys, right? So when you plug these into your denominator, you're not going to get 0, all right? So these work. All right, and that's this lesson. We're just doing the rational equations. We're not going to do the absolute value.